Editorial Services West, in association with Field Test Journal, presents a DIY trailer tech how-to video installing Airlift's Load Lifter 5000 Ultimate and WirelessAIR systems.
Hey guys, it's hard telling how long we'll keep using the nicknames half-ton, three-quarter ton, and 1 ton for pickup trucks because these vehicles have long exceeded those payload capacities. In fact, today's half-tons have several models by all the manufacturers that are approaching 1 ton of payload capacity. The fact that these vehicles can handle so much payload actually presents a challenge to the guys that are designing the suspension systems. I mean, after all, they don't know what you're going to haul in that truck. You may drive it around empty, might have 300 pounds in it, you might have 1,900 pounds in it. So what do? Do they tighten up the suspension so it rides level at capacity, but then it's just as stiff as a buckboard when you're driving around empty? Or do they keep a nice soft suspension system for when you're driving empty and then you're cruising around at 45-degree angle when you have a load on it? Now what would really be cool is if you had a suspension system that was adjustable. And that's the idea behind the Load Lifter 5000 Ultimate Adjustable Air Spring System by Airlift. At the core of the kit are convolute bellows constructed much like a tire with layers of rubber and cord that can handle pressures up to 100 psi. Nuts, bolts, mounting hardware, brackets, roll plates, fittings, and hoses are all included. We also used Airlift's WirelessAIR automatic leveling digital onboard compressor system. It comes with a compressor, air fittings, electrical connectors, inline fuse, zip ties, complete wiring harness with relay, manifold, air hoses, compressor intake filter, and all necessary brackets. We assembled the air springs and brackets on the workbench, starting with the roll plates. We installed the 90-degree swivel elbow fittings through the roll plates and into the air springs. We aligned the upper brackets with the openings in the roll plate. We fastened the upper brackets with 3/4 inch flathead screws through the roll plates into the air springs. We found the arrow stamped in the lower bracket and turned it so it was pointing to the outside, that is the opposite side from the side with the air fitting. Notice that the slotted ears on the lower plate angle away from the air spring. We fastened the lower plates to the air springs through the roll plates using the same type of screws that we used on the top plates. We put the large washers on the 3/8 by 1.5 hex head bolts. We found in the kit a wire with a coil at one end. This was the wire leader tool which we threaded onto the end of the bolt. We started our work on the Chevy by removing the rear wheels and tires. There are some lines that need to be slightly rerouted to make room for the air spring kit. We started with these brake line clips on the top of the frame just ahead of the axle on the driver's side. We also removed the ABS line holders on both sides of the truck by popping them out of the frame and removing them from the lines. These holders would be replaced by those supplied in the Airlift kit. We used a socket with an extension to remove the bolts that held the jounce bumpers in place. With the bolts removed, we wrestled the jounce bumpers out of their mounting plates. We located the bracket, which holds the brake line in place, at the differential. The Airlift kit includes a bracket to change the routing of the brake line up higher on the differential. With the wires and brake lines rerouted, we put the air spring assemblies in place between the axle and frame. We threaded the wire tool into the frame opening and the hole in the bottom of the frame. The bolt and washer followed right into position. The U-bolt goes toward the front of the truck over the frame and hangs down to the corresponding holes on the bracket. We position the ABS wire bracket between the upper bracket and the washer. It took a few tries to find the right combination of socket and extensions to work in the hole of the frame. We put the 2.25 hex head bolt through the J bracket and through the truck mounting point before threading it through the lower bracket on each side. We tightened the upper bracket in line with the hole in the frame for the ABS mount and torqued the nuts to spec. At the lower bracket, we adjusted the position of the air spring front to back while tightening. We learned to give attention to centering the lower bracket over the axle while tightening the bolts. It was a matter of matching the alignment on the front and the rear of the lower bracket on the truck mounting points. We started our install of the wireless air system by attaching the intake filter to the air compressor. We found this gusset where a crossmember meets the truck frame was a good mounting point for the compressor. We had some scrap 1/8 inch plywood on the job that we used to cut a template for the compressor. This didn't need to be exact, we could just kind of rough it out. So we cut it both directions, held the compressor over the template wood piece, and drilled into the holes enough to mark their locations, then drilled all the way through them. After positioning the compressor, we marked the foot locations for the outside with the drill bit. We drilled 2 outside holes that correspond to the mounting holes on one side of the compressor. We used roofing tacks to line up our template with the first 2 holes in the bottom of the gusset. Then we used the template to locate the 2 inside holes. We put the mounting bolts into the holes for the 2 inside mounting points before placing the compressor into position. We use one of the mounting bolts for the compressor to also mount the compressor relay. Before mounting the manifold, check out the designated orientation options in the instructions. We were able to mount ours in the preferred position. We used this little bracket that came with the kit to mount the manifold by first attaching the bracket to the manifold. We mounted the manifold on the same gusset, but on the forward side of the crossbeam. We put the manifold in a good position on the gusset and marked the edges. We aligned the manifold with our edge marks and marked the bolt locations with a small drill bit. We finished our bolt holes with the appropriate size bit. We put the bolts in the bracket and held them in place with tape before inserting them into the holes we drilled in the frame gusset. We tightened the nuts on the manifold bolts and plugged in the wiring harness. We used butt connectors to splice the engine bay harness to the compressor manifold harness. We slid shrink wrap tubing over the wires before completing the butt connections. We used a heat gun to shrink the tubing and weather seal the butt connections. We used a utility knife to scrape away some undercarriage coating to improve contact where we attached the ground to one of the compressor mounting bolts. We use the compression fitting on the compressor hose to attach a hose that goes from the compressor to the manifold. Most of the hose fittings in the system are push-in connectors. Route the hose, get a clean cut, plug, and go. We ran hose from the manifold to each air spring. We interrupted the hose from the air spring to the manifold with a T connector for installing an air valve at the fender well. We drilled holes through the fender liners for the emergency inflation valves on each side of the truck. We put a nut and a star washer on each of the inflation valves before putting it through the hole into the fender liner. We used a rubber washer, a fender washer, and a nut to secure the inflation valve to the fender liner. We prepared the inline fuse wire by attaching the appropriate terminal. We routed one end of inline fuse wire from the truck fuse box back towards the harness wire coming from its route along the firewall and trimmed the hot leg of the wire to length. We used a butt connector to attach the red harness ignition wire to the inline fuse wire. We installed the inline fuse. We use the supplied fuse adapter to get power from the fuse box at the unfused side of an ignition-powered fuse. We used a multimeter to find the unused side of an ignition-powered fuse by turning the key ignition on and off while testing the fuse connector output. We routed the ground wire along the top of the firewall and zip tied it to the OEM wiring harness following the same routing. We attached a terminal connector to the ground wire and attached it to the negative battery terminal post clamp. After putting batteries in the remote control, our system fired right up. The airlift remote allows the operator to control the air pressure in all airbag equipped corners at once or choose combinations. Air pressure can be adjusted from 5 to 100 pounds, providing a significant change in ride height. The controller enters sleep mode when no button has been pressed for 30 seconds. Press any button to wake up the remote. It will display the currently set PSIs. Pressing one of the memory buttons will fill or release air to the preset pressure stored in that memory location. Pressing the up or down arrows will change the PSI by 10 pounds per button push. As part of our testing for the system, we loaded up a 775-pound ATV and hitched a trailer with 500 pounds of tongue weight. It took about 50 seconds for the system to fill from 5 pounds to 55 pounds, but we've speeded up the video so you can see the difference in ride height. This airlift helper spring system is one of our favorite upgrades for the 2014 Chevy Silverado 1500. We have no intention to haul more or tow more than the capacities that GM designates for this truck, but this system provides for adjustability for all the variety of loads that we do haul and tow. Now, it makes things safer, it makes it more comfortable, it changes the attitude of the truck, and it keeps the low beams out of the eyes of oncoming traffic when we're hauling at night. This all adds up to making this airlift system a great upgrade for this Chevy.